Hello everyone and welcome to our training devoted to Cuba Platform data manipulation. My name is Yuri and I represent the development team of Cuba Platform. So I will guide you through the key features of the Cuba Platform for data manipulation and show you how to work with data, with transactions, with database in your Cuba apps. The target level of this session is the beginner level, and Cuba Framework experience is not mandatory today. However, basic Java Standard Edition and databases knowledge is required. And a few words about the process. I will show you platform features and examples today. We will also create a demo project or parts of demo project. Welcome to session and get ready to learn. This lesson we will focus on the platform components for data access. We will try the low-level data access mechanisms on the middleware and the unified interface for accessing data from a web client. And in addition to this, we will address the topic of data security and learn how to use the pessimistic lock-in mechanism. And at the end of the session, I will show you how to employ REST API for a simple data manipulation, for instance, from external systems or for mobile clients. Let's go to the data model of our project today. In today's lesson, we will use the workshop application as an example. A workshop application is just a simple and small sample project where we have implemented a workshop, a bicycle workshop with clients, orders, mechanics, and spare parts. So just small basic ERP system for a bicycle workshop. So it has really simple and small data model, as you see. So we have now four base entities: clients, orders, mechanic, and spare part. So let's talk about the Cuba and ORM in Cuba platform. The platform enables building applications according to the classic three-tier pattern. We have client tier, middleware, and database. Pretty standard architecture for enterprise systems. Middleware. The middle tier contains core business logic of the application and provides access to the database. So here we develop our business logic. Web client or desktop client. Client blocks, so client tier. Web client is the main block of the client tier in all the applications. It contains the interface designed primarily for internal users, for business users, and the user interface is implemented on the base of Vaadin framework. Also, we have desktop client for desktop apps, and it is an additional block of the client tier. It is not required in your apps. Also, you can use web portal module to implement custom websites or custom web portals. And in addition to this, we have Polymer client. It is an optional client designed for external users and written in pure JavaScript. It is based on Google Polymer technology and communicates with the middleware using REST API. So Polymer uses either web client REST API or web portal REST API. REST API is a generic REST API of Cuba platform. In fact, middleware is the mandatory block for any application. Other blocks are not mandatory. Usually, user interface can be implemented using web client or Polymer client. And if you want to implement custom web portals, we recommend to use web portal module. So now you see all the architecture. Now let's talk about the ORM layer. ORM layer is the component of middle tier. So here we have connection to the database. What is the ORM layer? In fact, Kubeflow Platform uses a special ORM layer to access the data from middleware. Object relational mapping is a special technology for linking relational databases to programming language objects. In our case, to Java classes. So we have object mapping for objects, for Java objects, and database tables. ORM layer has a couple of benefits. First of all, it enables working with relational databases with simple Java objects. It simplifies programming, and it ensures easy porting of the application to different databases. For instance, in Cuba, we support a lot of databases from HSQL and to Oracle and PostgreSQL. Also, ORM layer has a couple of shortcomings. First of all, it requires understanding of how it works, so how the ORM works. And also, it makes direct optimization of SQL and underlying SQL technologies difficult, you know. Okay, now let's talk about the main interface of ORM layer. So the main interface of ORM layer is persistence. Persistence is the special Java interface for your database operations. On middleware, we use the persistence interface, which is infrastructure interface of Kubeflow Platform, serving as an entry point to data storage functionality. The interface has the following methods. It can create transactions or get current transaction. Also, we have the main method, getEntityManager. It returns the EntityManager instance bound to the current transaction. Also, there are methods for soft deletion control. You can enable or disable soft deletion mode. So setting this property affects all newly created EntityManager instances in this transaction. Also, we can use underlying data source, underlying Java SQL data source instance for the currently used database. If you want to use native JDBC operations, you can use this method, getDataSource, to access the low-level database mechanisms. Now, in this session, we will use EntityManager as a low-level mechanism. EntityManager is the main ORM interface for working with persistence entities. Reference to this object can be obtained via the persistence interface by calling its getEntityManager method. And the retrieved instance of EntityManager is bound to the current transaction. So if you call getEntityManager many times, it will return one and the same instance each time you call it from the same transaction. And this instance of EntityManager contains a persistence context, and it is a set of instances loaded from the database or newly created. So if you know about JPA standard, or you used Hibernate or other JPA technologies, you may be familiar with these technologies. So the EntityManager has three main methods: persist, merge, and remove. And you see the description here. So persist method adds a new instance of the entity to the persistence context. Merge copies the state of the detached instance to the current transaction. And remove method removes an object from the database. And in case of soft deletion, it just set delete as and deleted by attributes. So the last thing before we start the practice is entity states. There are three main entity states in persistence context. Entity can be new, managed, or detached. New instances just created in memory. So you just create new instance and it is new. Managed instance, an instance loaded from the database or instance that has been merged to context. And detached entity state is just state of entity that detached from persistence context. Okay, now let's proceed to the KubeStudio and to the practice part. So I open my workshop project and let's talk about the project structure and project properties. First of all, please open project properties and check database connection. So let's check database type. It is PostgreSQL. I use localhost, PostgreSQL, and workshop database. And also I use Cuba credentials for database. So let's check the database connection. So please click on test connection. In my case, it is successful. Just save the project properties. Now let me open the project in IntelliJ using ID button. You should start your IntelliJ before you try to click on ID button. So I've started my IntelliJ instance. So now I have IntelliJ up and running. Now let's talk about the project structure. So I have started my IntelliJ. It is up and running. Also, I've installed a Cuba platform plugin for IntelliJ. And I go to the project using ID button. Just open it my IntelliJ instance. Let's see what we have in this project. So I will switch to presentation mode. So here we have pretty standard Cuba project with 4 modules: core, global, GUI, and web. In global module, we have entity package. Here we have client, mechanic, order, service, spare part, and special offer entities. So we have 4 main entities and we have service and special offer entities in addition. Also, we have one service. It is just order service. It calculates amount for order instance. So for instance, we can go to order service bin and check the implementation. Just close it, go back to project structure. Also, we have web module with UI. So here we have pretty standard CRUD UI for client, for mechanic, order, and other entities in the project. Also, we have extended main screen, so just standard main screen with side menu. So just generated with side menu template. And here we will create our additional services, middleware services, and UI today. So pretty standard CRUD project based on Cuba platform. Now let's go back to KubeStudio. So I just switched to KubeStudio. Let's start our session by creating a service. So we will create a new middleware service using middleware section of the navigation panel. I will create new service here, new service, and it will be spare part service. So I just change interface name in KubeStudio. When I click OK, Studio will automatically generate interface and Java class for me, and interface will be added to the global module, and implementation will be created in the core module. So let's check the interface code here. So it will be spare part service. And if we check bin, it will be just simple Java class that implements spare part service and with special annotation service. Kubernetes Platform uses distribution architecture that enables us to use the same services from different clients. For instance, we can call middleware services from desktop, from web portal, from web client, even from Polymer client. So for instance, we can deploy a web server and a middleware server to different machines, and we still will be able to call middleware services from all the clients. So now let's just check that we create spare part service and click OK. Now let's navigate to the created service classes using ID button. I just click ID here, and now I'm in the IntelliJ. Just switch to presentation mode. I have spare part service being class. It is empty. Now let's declare a new method. We should declare methods available for call from clients in the interface. So I just use Control and click on spare part service, or you can use Control plus B shortcut and go to spare part service. Here I will declare the following method. My business method will return previously used spare parts. So I will use list of spare part as result. Let's import Java util list. It will have name get used spare parts. So I will return list of spare part and get used spare parts. In fact, you can use any return types here, but there is a small limitation. They should be serializable. So you have to use serializable results. In my case, list is serializable and spare part is serializable too, because standard entity is serializable object. So in case you want to create custom Java classes and return them from middleware services, please ensure that you marked your custom classes as serializable. Yep. Okay, I've added this method, get use spare parts. Let's go to the spare parts service bin. So I just click on this navigation button at the left of spare part service name. Just click it. And I'm here in spare parts service bin. Now we can generate a stub for this method. So let's do it. So I just click on spare parts service bin. You can find this red bulb, or you can use Alt-Enter shortcut. So I just use implement methods action. Just use it. Oh yeah, generate stubs. Okay, here I will write my implementation of the business method. In order to start work with database, we have to use persistence interface first. So let's inject this interface in our class. So let's try to inject it. Alt, insert, inject. And I want to inject persistence. You can use code generate menu in IntelliJ, or you can use Alt insert and inject option. So Alt insert, inject. Let's find persistence. That's it, and inject it. Now we can use it in our code. In order to use database, relational database, we have to create a new transaction. Because if we try to use persistence and its methods without active transaction, we will have exception because there is no active transaction and we cannot perform database operations. So let's start with a new transaction, and I will use standard try with resources transaction option. So let's try. We have to obtain a new transaction instance, tx. Please use com Cuba core transaction and not the Java EE transaction and not the Spring framework transaction. So transaction tx, and we set persistence, create transaction here. So that's it. So we create new transaction instance here. And here we just call tx.commit to commit transaction instance. When we want to work with database, we have to obtain the EntityManager object inside of the try block corresponding to our transaction. So let's obtain EntityManager. So here we can obtain EntityManager. Just EntityManager, em, and get it from persistence. Get EntityManager. That's it. Now we can try to load used spare parts from the database. So as I said before, we should use query. So query interface is intended for running GPQL queries, and we can obtain a link to a new query from the current instance of EntityManager. So let's create a query. So EntityManager dot create query. Here in this string, I will write my JPQL query. It is not regular SQL query. It is object-oriented query in JPQL language. So JPQL here. It operates with entities and attributes and not the tables of the database. So let's try to select something. I will select spare parts, distinct spare parts from workshop order P, and I will join my O from O, and I will join O.parts. See, here we use attribute names and not the database tables. Join O parts P. Then I will add where. So I will plus where part, where we want to load used spare parts not for all the time, but for the latest week. So for latest 7 days, let's say. For this purpose, I will use special macro. It will be between macro, so between, and here I will use p create TS. Create TS is a standard system attribute for a standard entity. It is set automatically, so there is no need to set create TS in your code, because it will be set when you commit new entities to the database. So between create TS, now minus 7 days, and now plus 1 day, and in days, so day. Okay, so now we can load parts, and we can check that it was used, so it was added to order in the latest week. Okay. Also, we can use typed queries, and usually we recommend to use typed queries that allows you to return typed result. So let's try to use typed query. So I will add to my query type of result. It will be spare part. So I wait for spare part.class result. So here I select parts, and it will be a list of spare parts. So let me write here list of spare parts. And what's wrong? Oh, sorry, I just forget to obtain typed query instance. So before I obtain actual result, I will have typed query with type of spare part. Parts query. Oh. Just okay. Now, when I want to load my data from database, I just use getResultList method. So get results from the database. It will be parts list of spare parts. But before, I have to specify which attributes of spare part I want to load. Usually, we recommend to set view name of your query explicitly. So let's set parts query set view name as local. So you can use this value, or you can use constant from view class. View complement Cuba core global, view local, for instance. In this case, this query will return all the standard attributes, excluding reference attributes, so excluding relations. So I want to load only local attributes. It will not load system attributes by default because local view doesn't contain create TS, update TS, delete TS attributes. And if you want to load system attributes, you have to use separate view with system attributes. So in fact, view is just object that specifies which attributes of entity should be loaded from the database. There are 3 standard views for each entity. We have minimal view. Minimal view includes only small amount of attributes, includes only attributes required for simple string representation of entity in UI components. For instance, title or name or order number, something small and simple for view, for representation of the entity in UI or in strings and so on. We have local view. As I said before, local will include only attributes without relations, just string, integer, double, big decimal, boolean, and so on. And also we have base view. Base view is a concatenation of local and minimal. So base view includes all the local attributes and all the minimal attributes, because minimal view can include relation. Okay, so I will use local in my case. After that, we perform commit and we return parts. Now I can remove this return at the end of the code. Now we have manual transaction management. So we create transaction manually in this code. Then we commit it right here, you see, and we manage our transaction right here. There are a couple of additional methods to manage transaction, and I will show you how to use them right here. But before we'll try to run this query. If the query is intended for extracting the entities, it is recommended to use create query with type, as I said before. So here we get a list of spare parts. Now let's create a UI screen in order to display this list and show these used spare parts for users. So in order to display a list of these entities, we'll create a screen in Studio. So let's go to Cubo Studio back, and I will create new UI screen. I will select Web Module and click New. Here we will use blank screen template, so just go to blank screen template and change your descriptor name to used parts. It will be used parts screen for of application. So let's create and open this blank screen. Let's switch to the Data Sources tab and create a new data source. Usually, if you want to display something, if you want to show some data, for instance, a table or a tree or something else, you have to provide data using data sources. So let's switch to the Data Source tab. So let's create new data source. It will be collection data source because I want to show list of spare parts. And I set entity to spare part. So it will be spare parts DS. Okay. And I will use view local because I want to load local attributes. In fact, this data source will be used only for displaying the list of spare parts instances obtained from the service call. So let's check do not refresh checkbox here. So this data source itself will not load data. We will use it only for data for table as data container. So this data source will not load data from the database. Okay, let's switch to the layout back and add table. So I will create new table. Just drag and drop table here. Let's set width and height to 100%. Just expand in horizontal and vertical directions. Just use these buttons, or you can easily set width and height using properties panel. Okay, now let's set data source. So I just go to properties of this table and set data source to spare parts DS. Now you see this table will show title, description, and price, all the local attributes. Now let's save the screen and switch to the ID to add business logic to the controller of the screen. So just click OK. Select useparts.xml in my generic UI section and click on ID button. So now I'm here in the XML of the screen. I can switch to use parts Java using class attribute. Just use Ctrl+B shortcut, or use Ctrl-click to go to get to use parts class. Here we will override init method. So you can use code override or Ctrl+O shortcut. So I will override init method. So here we will have init. And also we will need the access to the database, to data source, and the service from this method. So let's inject data source and service in this screen. You can use code generate menu or alt insert shortcut. So I will inject spare parts DS, and also I will inject my service. It will be spare part service right here. So you will see the same picture. You'll see spare part service injected and spare part DS. Here we will invoke the service method in the init method, and all the retrieved spare parts will be added to the data source. So let's call service first. So spare part service, get used parts. Get used spare parts, of course. It will be a list of spare parts. Let's see parts. And now we can easily show this list of parts using special method of spare parts DS. So I will simply iterate parts, and I will add spare parts to data source using include item method. So I will add each part to the data source using include item method. Actually, there are two similar methods in data source. We have include item and also we have add item. What's the difference between them? The difference between this method and add item is that add item method marks the data source as changed and includes added instance to the commit list for later commit. Include item doesn't mark the data source as changed and does not include the added records in the commit list. So we will add parts from service just for display purpose. So we will simply show list of parts in table. We will not change them or commit them to the database. Okay, now let's try to start the application and see the result. So how it look like, and let's go here. First of all, let's create the database using run create database action. So please create database using Cuba Studio. So it will read all the database scripts and apply them to your PostgreSQL database. Now, when you successfully created your database and deployed your application to local Tomcat instance, we can start the application and try to use it. So let's start it using just this button or use run start application server. And now, while I'm waiting for Tomcat to start, I will show you the database in PostgreSQL in pgadmin. So let me show you PostgreSQL admin application. So here I have my test database, empty database workshop. So I can easily connect to this and, let me just refresh my databases list. We have workshop database. Let's check tables and schemas. We have only one schema, public, with all the tables. In Cuba, we usually use only tables, views, and we do not use triggers, we do not use storage procedures, we do not use, I don't know, functions. So we use only tables and views. But you are not limited with this functionality. If you want to use any feature of your database, you can use it. But in Cuba platform, we just want to have portable code, and for this purpose, we do not use custom features of particular database, for instance, of Oracle or for, let's say, Microsoft SQL. So if you check your database, you will find only tables and maybe only one function, new ID for unique identifiers, and indexes, and that's it. Here we have a lot of tables. Some tables goes from Cuba itself, for instance, for security. So we will have sec prefix and sys prefix for Cuba platform tables. So for instance, for users, roles, settings, I don't know, maybe for filters and so on. Also, here we will have tables for our entities, clients, mechanics, and so on. And if we check standard entity, for instance, client, we'll have standard columns, ID, create TS, version, update TS, delete TS, and so on. So usually we have you know, 7 system attributes. Let's proceed to the application. Now let's go to the application and let's create a couple of test records. Let's go to spare parts. So application, spare parts, and let's create a couple of spare parts. Let's create first spare part will be, let's say, wheel 27 inches, and it will be, let's say, standard wheel, and the price will be, let's say, $20. Okay. Also, I will create, I don't know, maybe a spoiler. Why not? And price will be 50. Okay. And the third one will be, let's say, seat. And it will be 100 for seat. That's it. Now I have 3 spare parts. Oh, let me add descriptions. Let's say carbon. I don't know. Now let's create orders that will use our spare parts. So let's go to orders and create a new order. It will be, let's say, wheels problem. Now I have to create client. Let's create client. It will be, let's say, Alex with phone number 111-11, all the ones, alex@home.com. Okay, select it, and also I have to create mechanic. Let's hire mechanic, let's select administrator as mechanic, add test data, and so now I will create just one order, and I will add spare part with name wheel, because we have wheels problem. Okay, now I have test data. So we just created service being, one business method, and we have implemented one UI screen that will show list of entities loaded with EntityManager. So let's try to call used parts screen. So now if I click used parts in my application, I will see wheel 27 inches, standard wheel, and price. That's it. So we just loaded data using EntityManager, using programmatic transaction management. We just create a transaction and terminate it manually. So our current version will roll back in case of error automatically. In addition to creating and committing transactions manually, we can use functional transaction management approach. So let me show you how we can employ it. So I go back to my business method. Here I will rewrite my method with return, persistence, create transaction, and use execute method with EntityManager. I just copy my code here and I will use shorter notation. Turn, let's say it. Just remove additional code. So here we replace our code with this version. We use execute method of persistence of transaction actually, sorry. Here we will receive EntityManager automatically in this Lambda expression. There is no need to commit transaction manually, just functional approach for transaction management. And if I reopen my screen, the result will be the same. So if I go to the application and just open it, and that's it, and check if my KubeStudio have deployed my spare parts service bin to Tomcat instance, so deploy it. And if I reopen it, just the same result. So that's it. So pretty useful syntax, you know. Okay, in addition to programmatic transaction management, we can use a special annotation, special transactional annotation to indicate that the method requires a transaction. So I will change my code. So just remove this version and add this. Also, I will add transactional annotation from Spring Framework. So I use org Spring Framework transaction annotation class. So here we use transactional. There's no need to create transaction programmatically. It will be created automatically and committed right after the method call. Also, if there is an error, it will be rolled back automatically too. So just really useful option. This declarative transaction management approach allows you to reduce the amount of boilerplate code, but it has one known drawback. Transactions are committed outside of the application code, and often it complicates debugging because it conceals the moment when changes are sent to the database. So additionally, please keep in mind that declarative markup will only work in the method called by the Spring container. So your method have to be declared in service or in bin interface. So according to that, we usually recommend using declarative transaction management only for simple cases like a service method reading a certain object or returning it to client. For this case, it's just really useful practice. So that's it with EntityManager, with low-level mechanisms. Now let's talk about the DataManager. What is the DataManager? DataManager is a special abstraction for clients, for desktop client and for web client and for web portal. It is the API for transaction management in clients, and API for manual transaction management is unavailable for clients. So we can use only service calls or DataManager interface. DataManager is a universal tool for loading and committing entity graphs from clients. DataManager always starts a new transaction and commits it on operation completion. So DataManager starts all the transactions automatically. DataManager has many useful methods. Let me show you in the IntelliJ. So let's go to DataManager interface. DataManager. We can load entities, or we can load list of entities. Also, we can easily commit entity or entity graph in this case. And usually it is really useful for client code instead of writing manual services. So if you want to load data in your UI screen, you can simply use DataManager instead of custom service bin. For instance, our previous example can be easily replaced with DataManager. So let's try to replace the method call of service bin with DataManager. So let's talk about this topic. I go to UI screen to use parts, and let me hide imports for this. I will remove spare part service from here, and I will replace code that loads data from service bin. Instead of this service call, I will use DataManager. So DataManager. I will inject my DataManager as before and use load list method. Load list method requires load context object. So I have to provide load context. It is typed with type of entity of spare part. LC. I will create new load context. It will be spare part.class. Also, I will set query and view for this load context, like here. So query is the same as before, and we set view local. Here we perform load list with this load context, and it will be a list of spare parts. So we can easily load data without custom services using this DataManager. Let's try to reopen UI screen. So if I reopen it, I will see the same result, but let's change something to see the difference. For instance, I will load all the data without the where condition, just load all the spare parts. I still load parts from order. Let me load all the spare parts. Just load P from workshop spare part P. That's it. That's the right GPQL query. So we check that used parts deployed to Tomcat instance. Deployed. So now let's try to reopen screen. That's it. I see all the spare parts. Now let's talk about the next topic for today. Let's talk about the entity listeners functionality. So I just tell you about the entity listeners. Entity listeners are designed to react to the entity instances lifecycle events on middleware. A listener is a class implementing one or several interfaces from the component Core listener package. The listener will react to events corresponding to the implemented interfaces. In the system, let's add a new number attribute to the order entity to give each order a simple, memorable number. This attribute will be shown in the orders table, so the value of a number will be filled automatically using entity listener. So let's try to implement this automatic numbering of orders. So let's go back to Cuba Studio and change data model. So I will stop my application. and change data model. Let's go to data model and open order entity. So here we have attributes. Let's add new attribute. It will be, let's say, number with type of long, and it will be mandatory. Yep. Let's add it. Now let's save the entity using OK. And here you will see Studio suggests adding the attribute to existing screens. So specify that the attribute should be added to only workshop order browse. So I will add it only here to this table. And click OK. Now let's generate database scripts using special action in data model section. Generate database scripts. And click Update Database to execute Update Order SQL. Now I've added the attribute. It is mandatory, and I have to provide automatic numbering. Let's go to the middleware section and create an entity listener. So I will click on New Entity Listener. I will set before insert entity listener checkbox. And let's say it will be order entity listener. So I will change entity type to order, and it will be order entity listener. Now, if we check source code, we will see just simple Java class annotated with component annotation of Spring Framework. So basically it is a bean. It's a component of application. It implements before insert entity listener interface with type of order. And here we have only one method before insert. Let's save this stub and proceed to the ID. So just click ID button. So now I have order entity listener here, and I wanna set entity number automatically. In order to do this, let's inject unique numbers API. So you can inject unique numbers API the same way as before. Just use Alt Insert or code generate menu. So please inject unique numbers API. Unique numbers API is the mechanism that enables unique number sequences through a simple single API, no matter what database is used in your project. So it's just cross-database API for unique sequences of numbers. Let's set new number for entity in before insert method. So entity set number using unique numbers API dot get next number, and we have to provide name of sequence. So I will use order number name of sequence. This sequence will be created automatically in the database. There is no need to generate SQL. It will be created at runtime. And that's it. Now we can restart the application and see how it works and how we can automatically assign numbers. Let's go back to KubeStudio now and start the application. So I just restart the application server and wait for Tomcat instance to start. So if we create an order now, this entity listener will be fired and will automatically assign a number to order in the same transaction that is used to insert the new order into the database. So entity listeners work in the same transaction, in active transaction that performs some data operation. So let's open the application, log in, and try to create new order. So just go to orders, create a new one for the same client and with the same description. Okay. And the mechanic, let's say administrator. And now we have number first. Yeah. So that's it. It is automatically generated by entity listener. It is really useful if you want to perform additional operations in your database, such as encryption, such as maybe calculations, additional calculated fields, and so on. And in fact, in this order entity listener, you can even use EntityManager. So you see, we provide EntityManager as parameter, so you can easily get or find instances of another entities and check fields. You can modify them and so on. And all the operations will be performed in the same transaction as a change of this entity. Okay, let's proceed to the next topic. Now we will talk about the soft deletion. So soft deletion is a special mechanism of the Cuba platform. It is really useful for enterprise systems. Cuba platform supports soft deletion mode for data when the records are not deleted from the database, but instead marked as removed in the database using simple attribute, special attribute delete TS. So if you check standard entities, for instance, user or maybe role, you'll see delete TS and deleted by attributes. Delete TS attribute is used for soft deletion mechanism. It is set to value when this entity gets removed. So soft deletion mechanism is transparent for an application developer. The only requirement is for entity class to implement special soft delete interface. And the platform will adjust data operations automatically. So soft deletion mode offers a couple of benefits. First of all, reduces the risk of data loss. And the second enables making certain records inaccessible instantly, even if there are references to them. Using our model, orders clients data model as an example, let's check how it works. So I will go to my application. There is order browser. And let's try to remove client, for instance. Why not? I will go to client browser and just remove it. Yeah, sure, remove it. There is no clients anymore. And in fact, if we check database right now, we will see that data is not removed. So let's go to PG admin and check for workshop client. Let's open data, let's say view data all. You see there is a record, and delete TS is set to the moment of removal. That's why we do not see this record in client browser, because delete TS check is added automatically to all the queries to client entity. So there is no need to include custom where conditions to our queries to database. Okay, now let's try to restore this entity, because if we use soft deletion, we have ability to restore data. So let's try to use special administration UI for data restoration. Let's go to administration menu and open restore deleted entities menu. Here we want to restore client, and now we can restore this instance. Just restore it. Yes. Actually, we can even restore entity graphs, complex entity graphs. Let's open clients again. Now we see it is back. Okay, there's no need to call to client and say, sorry, we have missed your data, you know. Actually, we use soft deletion by default. Of course, if you want to remove data completely, you can do it if you set soft deletion in transaction to false. So for instance, you have to use persistence API. Inject persistence. So we can set soft deletion to false if we want to remove data completely. Okay, and also we can load remove data if we disable soft deletion the same way. Okay, now let's proceed to the next topic. Let's talk about the locks. So usually in enterprise applications, we want to use database locking for some entities to prevent simultaneous access to data and to prevent changing of the data in concurrent use. There are two options to prevent simultaneous access to data: optimistic locking and pessimistic locking. Optimistic locking, an approach to managing access to shared data by different users that assumes that there is a low probability of simultaneous access. With this approach, we do not lock instances actually, but instead we check if a newer version of data is available when we want to save a record. Optimistic locking is used by default for entities that implement versioned interface. For instance, if the entity derived from standard entity. So it is enabled for all the standard entities. Pessimistic locking required when there is a high probability of simultaneous editing of a single entity instance. In such cases, the standard optimistic locking based on entity versioning usually creates too many collisions. Pessimistic locking explicitly locks an entity instance when it is opened in UI editor. And as a result, only one user can edit this particular entity instance in a given moment of time. Let's try to see how works both types of locks. Let's open UI of application, and I will open my client and change something. So let's change name. I will open it again in the second tab and go here. Let's change Alex. It will be Alex789. Now, if I save client editor, let's click here Alex123 and save and close, and then try to close and save this client editor, I will have this scary red message. Object client was modified in another transaction. You know, I think you have seen this before. That means that another user have changed the same data, and there is a probability that you will lose data if you try to commit your data over previously changed data. So we cannot commit this instance. We have to reopen client instance and change data that was previously updated. So Okay. How we can use pessimistic locking to prevent such an opening of the same entity by another user. The pessimistic locking mechanism can be automatically enabled even at runtime without server restart. Let's see how it works. Let's go to Administration and open Locks menu. Here we can set up locking using Setup tab. Let's create new lock setup for, let's say, order entity. For instance, we want to prevent simultaneous access to order instances and set timeout to, let's say, 360 seconds. Okay. And apply changes using Reload Configuration button. Now let's try to open the same order twice. So let's open Alex here, and let's open another tab, and let's go to Application Orders and open it. Now you see it is read-only. There is a notification that shows record is locked by administrator since this time, and we cannot commit data, so we can only read data here. There's no option to save this. So we cannot commit data over previously opened. Now let's talk about the data security. So the platform includes built-in functionality for user account management and security. This functionality is available from the administration menu and includes role-level access, role-level model, dynamic attributes, data recovery, and so on. Cuba Platform uses the following methods to control user permissions and access rights. We use role-based systems, role-based system for assigning user permissions. So we can assign permissions for editing entities, for opening screens, for editing attributes, and so on. Also, we have hierarchical structure of access groups with constrained inheritance. So we can open access groups, we can add users here, and set up constraints. So access control at the following levels. So we have operations on entities, entity attributes, and access to particular entity instances using constraints. At the data level, security is checked by DataManager. That's why I have shown you DataManager. It controls the data taking into account, the role permissions on entities and attributes. By default, all operations with data in clients, in web, desktop, portal, and REST API pass security checks. So there is no option for client code to trespass security checks, to go without them. So let's see how it works, and let's try to use role-based system and role level access. Let's create a restricted role for mechanics first. We go to roles and create new role. It will be mechanic role. Here we will limit access to administration menu. So I will select administration menu and select all the screens and just deny them. That's it. Also, I will deny access to mechanics, clients, and services screens. So mechanics, clients, and services, deny. Now let's move on to entity constraints. So let's go to entities. Here I will deny access to our client mechanic spare part service and special offer. So client mechanic spare parts, special offer, and service, and I will deny create, update, and delete operations. Just apply that. Now let's move on to attribute permissions. So I go to attributes. Here I wanna set read-only for order attributes for client, mechanic, and description. So read-only for description, for client, and for, let's say, mechanic. So mechanic will not be able to change mechanic in order. And also I will hide amount from mechanics. Let's save this role. Let's click OK here. Now I want to create user. Let's create a new user. It will be, let's say, Jack with really security password 1 and with role mechanic. And let's save it. Now let's log out from the system and log in as Jack1. As you see, we have access only to application menu, and we can only use spare parts, orders, and use parts. There is no access to administration menu anymore. And if we check orders, we cannot change description, client, and mechanic, and there is no amount field, just hidden from user. Okay, now let's see how we can control access to particular instances of orders. So for instance, with access groups, users can be organized into hierarchical structure and assigned constraints. So the user can be added to one group only, but the list of constraints and session attributes from all the groups use hierarchy. So let's go back to administrator and check how we can create access groups. I will create mechanics group. So it will be mechanics, mechanics. And let's switch to constraints tab. Now we have to set an additional condition for order entity. So I will limit access to order instances, and I will limit access based on mechanic field. So order entity here. I will use read operation type, and I will check operations in the database. So I will set where clause. It will be e dot mechanic dot user dot id equal to special session attribute session user id. Session user id is a special attribute of currently logged in user, and ELS is a special alias of the entity being extracted. In my case, it is order. Let's click OK here, save the constraint, and let's move Jack to this group. So let's move it to mechanics. So user Jack has been moved to group mechanics. Now let's create a couple of orders for Jack. So I will go to application, orders, and create one more order for client Alex, and for mechanic, I will create mechanic for Jack. Whoop. And select it. Okay, now I have orders for administrator and one order for Jack. Let's log out and log in as Jack. Here, if we open orders, we will see only single order for Jack. So all security settings applied, Access groups enable row level configuration. So now we see we didn't change our code. We just set up our security settings at runtime without server restart. So you can easily set up your security configuration at runtime. But be careful, as any configuration, security constraints and security roles have to be tested before you change them on production, you know. Okay, let's go back to the presentation and talk about the additional topics. I want to show you one useful class. It is called Persistence Helper. It is a helper class for obtaining the information on persistent entities. It can be used from any tier, and it has a couple of useful methods. For instance, we can check if entity is new, just useful. For instance, if you wanna change your business logic, for instance, in client edit or some editor, you can check in any method of window if your instance is new. So let me check if persistence helper is new, my get item. I can perform additional actions. For instance, I can show or hide my UI components, I can perform additional initialization, and so on. It has a lot of useful methods such as is deleted or is loaded that can be useful in your business logic. Okay. And the last topic for today is the REST API. So how we can use REST APIs in our applications. Often, enterprise systems have more than one client. For instance, usually we have a web client and web portal, or maybe a Polymer client. In our example, we have only a web client for our back office stuff. In the future, we could come up with we could come with an idea of having a portal or a mobile application for our customers. For this purpose, Cuba provides developers with the generic REST API. REST API is enabled by default in the web client. Thus, we can use it right now for a simple web page that will show the list of recent orders for a logged-in user. Let's see how we can apply it to our application. I go to Cuba Studio and open data model section. Let's select order entity and create new REST query. So new REST query. Here I will load recent orders. Recent orders will be name of my query. And I will use local view. Only local attributes will be returned to client. And let's set GPQL query. So I will load orders and sort them, order them by create TS. So we can copy query from the chat. So recent orders, this query, that's it. Click apply. Now we can create a simple, small HTML web page that will load data. So let's see how we can do it. I go to IntelliJ, open my project panel, and go to web folder. Here I will create a new directory with name Vaadin. So new directory Vaadin. Here Let's create orders.html page. Usually, Vaadin directory can be used for web resources, for CSS, for JavaScript files, and so on. For this example, we use it only as an example of static files location. So I will create orders.html file here, orders.html. So that's it, Vaadin orders.html. jQuery and Bootstrap mean CSS, just copy them and paste to Vaadin directory. And let's open orders.html. Here we will create our web page. First of all, I will just copy and paste my HTML code snippet. Here we simply create small login form, so we can copy code for HTML file here. We have label for logged in successfully. We have login form, just simple plain elements, and also we have element for recent orders, just a small client-side form. Our form consists of two fields, login and password. We'll send a login request to REST API on submit button click. Now let's create orders.js file. So here we have to create orders.js file, orders.js. Here I will write my logic for authentication and data loading. So here I will use this code snippet. You see, I get login and password from my web form. Simply perform auth token call with a special authorization header and content type. In data, I pass ground type, username, and password. And if this call is successful, I load recent orders using additional REST API call. I use localhost in my example just for simplicity. I use REST v2 queries workshop order recent orders, my REST API query. And after that, I will show order descriptions in my list. So login and load recent orders to element. That's it. So let's try our web page. So I will restart my application. So just OK and restart. Wait for Tomcat. Let's see how we can check it. Now you can open our page using this URL, app Vaadin orders HTML. So use this URL if you created this page and open it here. So now you see bike workshop login form, just simple CSS login form, just admin, standard login and password, and submit. After that, we'll see undefined description for one of the orders, okay, and Will's problem. So we have loaded data in JSON for entities. REST API of Cuba platform is generic. That means you will have automatic read, update, create, and delete methods for all your entities automatically. So there is no need to create REST API manually for simple CRUD operations. Moreover, for queries, you will be able to create REST queries right from the Cuba Studio. So you can go to data model and create your additional advanced queries right here without programming, without Java code. just register your GPQL queries right here, set view. For instance, I can load complex graphs if I want with additional data. Let me show you. Let's see order view, apply, and try to load orders and see data. I will open my debug console sources. Let's see orders.js, and let's check data loaded from the server side. So let's submit. Now we will have data for orders here, and also we will have amount, ID, number, status, and entity name. So here, oh, sorry, we have to restart the application. I have changed my query. Let me just restart up and see the result. Just restart it and try it again. Just starting my Tomcat. And now I can try to load data. Oh, yeah. Now you see we have obtained client reference, mechanic reference. We also have parts in this object. So we have complex data graph in our REST API. Okay. So now let me conclude our session. In fact, it was the last topic for today. So during this lesson, we introduced the main data access mechanisms. Learn how to use DataManager and EntityManager, as well as the built-in mechanisms for applying pessimistic locking and security to implement the application business logic. Thank you for watching, and see you soon on our community. So thank you guys, and bye.